Hey guys, today we are starting a unit on systems of equations. Anybody remember what a systems of equations is? No. They don't even want to think about it. They just don't remember. Yes, Lydia. No.
Isn't it like when it's like multiple equations that lead to the answer?
Exactly. Give it up for Lydia. Everybody give her a round of applause. She said multiple equations that give you the same answer. That's a good way of describing it. So multiple equations that give you, or let's just say with the same solution. Okay. So examples of that would be something like this. X plus y equals 1 and x minus y equals 15 or something. That's an example. So we've done problems like this before and solved them for an x and a y that fits in both equations. We're going to get, are you all ready for this? We're going to get into third order systems in this class. Yeah. If you did not catch that, it was okay. So third order systems, x plus y plus z equals 12. 2x minus 3y plus 4z equals 15. And I am making this up on the fly, so I have no idea what kind of solutions we'd get for this. But x plus 6y minus z equals 12 or something like that, or negative 12. All right, so that would be a third order system. So we're going to go through and solve these, and basically what has to happen is you're going to get an x, in this one an x and a y that works for both equations, this one x, y, and z. So this is like a three-dimensional plane. This one is x and y like this. This one we have still x and y, but we also have a third plane that like comes out of the page, and that's z. Whoops, actually it's backwards, but you get the point. It's three-dimensional. So imagine like the, let's see, do I have a box? Imagine like a cube, and this would be like the corner of the cube coming out, or a box of some kind. I don't know how many boxes. Tissue box? Yeah. Actually, here, let's draw. See if I can draw better. Okay, so if you can imagine, like, this is the corner of a box. Can you guys visualize that? Okay, so this would be the x-axis, this would be the y-axis, this would be z. Something like that. So you would go, like a point out here somewhere would be, it would have 3 coordinates, 1, 2, 5 or something. So you would go out 1 in the x direction, then 2 in the y direction, and 3 in the z direction. So it's somewhere up there. Does that make sense? Yeah. Okay. We're not going to spend a bunch of time doing that stuff, multivariable math, you could wait to get into the later math to do that. Okay, but we are going to go back to solving systems of equations. So we have multiple ways of solving them. The first way that we're going to focus on is graphing. So I'm going to switch the page over, and we're going to do a couple of examples. So solve by graphing. Okay. Ooh, what was that noise? Facebook. I do not have Facebook open right now. Okay. So, let's see. X minus 2y equals 7, and x plus y equals negative 2. So what's going to happen is we're going to go through and you're going to get systems of equations and be asked to just solve them, generally speaking, and not be told which way to do it. You want to know how to do it each way, which is why we're going to go through them, but actually let's color code this. But for the most part, you're not told which way you have to do it. All right, so x minus 2y equals 7. That's the first one, and x plus y equals negative 2. All right, so if we want to graph these two equations, can somebody remind me how we would do that? How do we graph? Let's start with x minus 2y equals 7. What do we do? Ashley.
You have to solve for y.
Good. So how do I solve for y here?
Subtract x.
Good. Subtract x. Everybody give it up for Ashley. Okay, hello. Everybody give it up for Ashley. Worst enthusiasm ever. Okay, negative 2y equals negative x plus 7. Perfect. Okay, then what next? I need my list here. What next? Kendra? Divide by negative 2. Everybody give it up for Kendra. That was better. All right, I will find my list in just a second. Divide everything by negative 2. So we have y equals 1/2 x minus 7/2, which, so that's the same thing as 3 1/2. Let me pause it for a second so I can find my list. I have someone in the audience who just volunteered to keep track of extra credit for me, and yes, actually multiple people volunteered, and we all want to know whether we get extra credit for keeping track of extra credit. That's how accelerated Algebra 2 works. All right, so next, x plus y equals -2. How do I get y by itself in this one? Akashni. Good, subtract x. So y equals -x minus 2. Okay, so let's go ahead and everybody draw a graph on your paper. And we're basically going to solve both of, or sorry, not solve. We're going to graph both of these equations. And there's going to be, I hope, a really obvious place that is the solution. Let's start with the easy one first. The one that's easiest for me to graph is the one that does not have fractions in it. Can somebody remind me how I would graph y equals -x minus 2? Stacy?
Well, first you take the y-intercept, which is -2.
Perfect.
You go into the y-axis and find the
Good. Okay, and then from there I do what?
You use the slope, -1.
Good.
And you go up 1 over 1.
Now if it's -1, am I going?
Down 1
That's
over
good.
1.
Down 1, right 1. Now, this is one where it's actually really good to continue the slope on and on and on. The reason for that is because we want to find a place where these lines cross. So if you use the whole keeping the slope going thing, you're going to have a more accurate graph. All right, so then we draw a line through it. That's the first line. Okay, how about the next one? 1/2 x minus 7/2. 7/2 is the same thing as what? That's 3 1/2. Okay, good. So, -3 1/2, that's the what? The what? The y-intercept. Okay, so -1, 2, 3 1/2, that's our first point. From there, the slope is what? 1 over 2. So where do I go from here? Up 1 over 2. Up 1 over 2. And so on and so on. Okay, and then we connect them with a line. Now you guys tell me, if we're looking at this, there should be what I hope is a really obvious place where these two lines do something that gives us a solution. What do we think? Where do they meet? Where do they intersect? What point is that? 1, -3. So write 1 down 3. So that, 1, -3, that is the solution to the system. Questions? Now, if you wanted to go back and do a check, how could you do that? Okay, good. Plug what in where? Marcy?
Oh, no, I have a question.
Go ahead.
If we have -3 1/2 and it's on not line, then how is it that one of our answers is over?
Okay. It doesn't have to be. What? Say that again.
So you know how our y-intercept is 3 1/2?
Mhm.
If we just do our regular side over 1,
Yeah.
it's still on a point that's not a whole number.
Yeah, it could be. So you can see some of these are. What ended up happening was the slope could also be looked at as 1/2 over 1, right? So if we go from this point up 1/2 and right 1, you can see we will end up on whole numbers. It doesn't have to be a fraction just because we have fractions here. Does that help? Okay, other questions? Okay. Do we want to do another one of these, or do you guys have a pretty good understanding? We have an understanding. Let me ask a question. What happens if the lines never intersect? When you graph them, what happens then? No solution. Okay, good. That was going to be my next example, but if you guys are good, then we don't have to do it.
You should do it, and then we can obviously have no solution.
Okay. Let's move on. Okay. This is the last kind of problem that you guys are going to see in your homework. Write an equation to describe each relationship. Right? And EQN, that's my shorthand for equation, to describe each relationship. Yes. To describe each relationship. All right. Nobody should be talking right now. I know you all are wonderful multitaskers, but zip it. Okay, the sum of two numbers x and y, the sum of two numbers x and y is 14. Their difference is 6. Okay, so all we want to do is we're basically writing a system of equations that fits these rules. So let's start with the first sentence. The sum of two numbers x and y is 14. How would I write that in a math sentence? The sum of two numbers x and y is 14. Haley? Perfect. X plus y equals 14. Okay, next one. Their difference is 6. How would I write that one? Stephanie, you want to do this one?
No.
Their difference is 6. The difference of x and y is 6.
Okay, x minus y equals 6.
Perfect. X minus y equals 6. And then you just put the curly brackets there, and you are finito. Questions on that? Okay, I want to give out more extra credit, so let's do 2 more. That's it. Yeah, you don't actually have to solve them. That just says write an equation or equations to describe the relationships. Questions? Yeah, Jade?
Are you going to do 2 more of the ones we just did?
Yes. Okay, here we go. Two numbers j and k. No. Were you all just thinking JK? Just kidding.
I just thought
Two numbers j and k. There are no words. We are in another world. Okay. Their sum of their reciprocals is 55. Reciprocals. That means there are fractions. Aren't you glad we don't have to solve these?
Yes.
Okay. The difference of their reciprocals is 71. So the difference of their reciprocals is 71. Okay. We didn't do a dedication. I did this last period. So this lesson is dedicated to Mr. Humphreys. And that's all we'll say about that today. Okay. Two numbers j and k, the sum of their reciprocals is 55. Can somebody tell me how they think that would look? Lydia.
I don't really know I don't know how you get to it, but I'm pretty sure the answer is a fraction.
Okay. Well, let me ask a question. The sum, if I just say the sum of two numbers is 55, is that the same thing as j plus k equals 55? Okay. What is a reciprocal again? So if I ask you what the reciprocal of 2/5 is, what is it? 5 over 2. If j over 1 is the first number, Rachel? That's good. Good. Plus equals 55. Whoops, we need the second one. Okay, good. The difference of their reciprocals is 71. So how would I write that one? If the sum of their reciprocals is 1 over j plus 1 over k, Hannah? Perfect. 71, and then curly brackets. Okay, questions? Yes, Lydia.
Okay, so how do you know which order the slip in it is just order the
Yeah, that's fine. All right, last one, and then we can do homework. Two numbers p and q. Everybody zip it. Shh. Underhill, is that you again? Oh, Di Stefano. All right then. Okay, their product is 15. Their product is 15. While the difference of the first, oh, you guys are going to like this one. While the difference of the first and 8 times the second is 3. Okay, two numbers p and q, their product is 15, while their difference, the difference of the first and 8 times the second is 3. Now you can assume that the first one is the first variable listed and the second one is the second variable listed, if that helps. So who can set up the first equation, the one that says the product of p and q is 15? Let's see. Michael? Perfect. P times Q equals 15. We haven't been giving applauses. Everybody give applauses for everybody who went that didn't get them. Okay, there were a lot of people in there. All right, next one, Ashley.
P.
Shh.
It wasn't actually.
No, it was actually.
Okay. P
Did you-
minus 8 Q.
Uh-huh.
3.
P minus 8Q equals 3. Okay, everybody give it up for Ashley. I know I hate this. Sorry, guys. Okay, I will work on that. Are there questions? No? You guys all anxious to get to your homework? All right, so it's homework 17. You are off the page. Let's see. Homework 17, page 115, written exercises 1 to 9, all in 10 to 16 even. All right, happy homework time. Yay.
Is it actually better?
Sure, let's make it an extra credit day.